Welcome back, class. Let's keep going with our discussion of inequalities, and let's take it to the next level and do some two-step inequalities. So hopefully you feel pretty good about one-steps and how to graph them, and so now we're just going to add on to that knowledge. So let's look at an example.
Did you know that the longest swimming pool in the world is the San Alfonso del Mar? It is located in Chile and is 3,324 feet long. Your swim team is planning a trip there, but it's going to be expensive, so you have some fundraising to do. Each team member must earn $2,000 to cover the cost of the trip. You get off to a great start when your aunt pledges $200. Then, the swim team decides to have a car wash as a fundraiser. For every car you wash, you receive $2 toward the trip. Let's work out the minimum number of cars you will need to wash to pay for your trip. In this lesson, you'll learn how to solve a two-step inequality for situations like this one.
Okay, go ahead and pause, add this to your table of contents, start a new entry, and today we're going to look at how we solve two-step inequalities. Alright, well, life is often more complicated than one step. So here's an example. Betty's planning her birthday party, and she wants a skating party. Mom is not made out of money, so she found a package that costs $50 plus $12 a person, and that gets you a table, skate rental, admission, pizza, soda. So her mom's like, hey, I got $200 for this party. So up to how many people could Betty invite? So we could use this inequality here to represent the situation. So here's our steps. We're going to solve them just like two-step equations. We're going to start by getting rid of the constants by adding or subtracting. Then we're going to move on to getting rid of the coefficients by multiplying or dividing. And then last but not least, we are going to graph those things. So go ahead and watch me. Alright, so I'm going to start with my constants. Boxing and circling, still all good things to do. Okay. See if my pen works. Alright, so if I box and circle this guy here, I'm going to get rid of my constant. So I got my x over here, I'm going to get rid of my constants. -7, -7, boom. Then I'm going to be left with 2x. Don't write an equal sign, that's where everyone messes up with these. And then I'm just going to get x by itself by dividing by 2, dividing by 2. And then I end up with my final answer of x is greater than or equal to 2. I'm going to sketch my graph for that. I'd put my 2, I would use an open dot, and I'm going to put my line going to the right. I'm going to use my little arrow trick. You really want a couple more numbers on there, but I'm trying to be quick here. Alright, let's look at this example. Box, circle. Trying to isolate that h right there. I'm going to add 4 to both sides to kill my constants. Sum that business up there. So I have 5h greater than or equal to 15. I'm going to divide by 5 to get my variable by itself. And I have h is greater than or equal to 3 as my final answer. I'm going to sketch a quick graph of this here. I'm going to use a closed dot because it's the equal to part, greater than or equal to. And I'm going to use my arrow trick and just draw my arrow going that way because I want all the numbers bigger than 3, including 3. Alright, go ahead and pause, write this down. So nice, we're going to write it twice. Alright, go ahead and do our steps from before. We're going to box and circle. We're going to go ahead and -2 from both sides to kill our constants. Put our little summing line here. So I'm left with 3x on this side. Use a less than symbol, not an equal sign. Put my 18 there. And then to finish this problem up, the opposite of multiplying by 3 is dividing by 3. So I'm going to divide by 3 on both sides. Bring down my x. Bring down my less than symbol. And then put 6. Box my answer. Make it easy to find. Alright, let's graph this thing. 6, 7, 8, 5, 4. I'm going to use an open dot because I don't want to include 6 in my solution. I'm going to use my arrow trick. Draw my arrow, going to the left. Alright, let's do one more basic one like that. And sometimes you'll see the variable on the other side. Don't freak out about that. And also, I'm going to challenge you not to totally rewrite the problem yet. Okay? All right, go ahead and write this thing twice. All right, let's ugly it up. We got some constants here and here. We got our variable hanging out here. Okay, so we're trying to get x by itself, so don't be tempted to minus 3. Again, what's over here with x? We're trying to kill the constant with x. Get rid of a plus 1 with a minus 1. Okay, 3 minus 1 is 2. Bring down the greater than or equal to sign. Bring down the x over 8. And then this business cancels out. Okay, trying to get x by itself. What's the opposite of dividing by 8? That's right, multiplying by 8. So times 8 on both sides. 8 times 2 is 16. Bring down my greater than or equal to. Bring down my x. Now I'm going to rewrite it because it's a lot easier now that it's shorter. And again, my symbol is open to the 16. So when I rewrite it, I'm going to rewrite my symbol open to the 16. So this is not wrong, but this is better. So let's do the thing that's better. Also makes it easier to graph. So let's sketch a quick graph. 16, 17, 18, 15, 14. There we go. All right, so I am going to use a closed dot because it's the equal to part, means I'm including 16. And I'm going to use my arrow trick now that I rewrote it and go this way because I want all the numbers equal to or less than 16. Okay, so far it's like, yeah, blah, 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 Miss Sharp. They're just like two-step equations. But there is a little catch, and we're going to do a little number experiment to find that little catch. So sit back, relax, watch me. All right, if I take this inequality right here and I add 3 to both sides, let's see what happens. Okay, 3 plus 2 is 5. Put my inequality symbol down. Negative 3, positive 3 is 0. Is this true? 5 is greater than or equal to 0, so yeah. That's true. All right, here's my inequality. I'm going to minus 1 or add a negative 1 to both sides. Same deal. And let's see what I get. Negative plus negative, you add, same sign. Copy my inequality. 6 minus 1 is 5. Is this true? Is negative 2 less than or equal to 5? Yeah. All right, what about here? Let's throw negative 8 on both sides and see what happens. All right, negative plus negative, you add, same sign. Copy my inequality symbol. Negative plus negative, you add, same sign. Be careful here. You might initially think like, oh, you know, like this is wrong, this is bigger. But negative numbers work differently. Would you rather owe 16 bucks or would you rather owe 18 bucks? So this is bigger, this is true. So far, as long as we do the same thing to both sides, everything's cool, just like with equations. So, what's the catch? Let's mix in some multiplying and dividing. So we're going to divide both sides this time. So I'm going to divide by 4, divide by 4. 4 divided by 4 is 1. Copy my inequality symbol. 8 divided by 4 is 2. 1 is less than 2. Everything's cool so far. All right, let's divide this one here by 3 on both sides. 12 divided by 3 is 4. Inequality symbol here. Negative divided by positive, my answer is negative, so that's negative 5. 4 is greater than negative 5, yeah. All right, Miss Sharp, what's the catch? Let's take a look when we divide by a negative. Negative divided by a negative, my answer is positive. I write my inequality symbol here. 12 divided by negative 4 is negative 3. And then, whoa, whoa, whoa. Negative 3 is not the bigger number here. 4 is. All right. Let's do another one because we can't believe just one experiment. What happens when we divide by negative 5? So here we go. We get negative 3, copy inequality symbol. We get negative 1. And you might think like, hey, that's cool. But again, negative 3 is actually smaller than negative 1. Owing $3 is worse than owing $1. So again, we see that's false. So when we divided by a negative, it actually made our inequalities false. If I wanted to make it true, I would have to move the inequality symbol and face it the other way. I'd need to flip it or reverse it. So if I do that, now everything's cool. Yeah, 4 is bigger, negative 1 is bigger. So when we multiply or divide an inequality by a negative number, you have to reverse or flip the inequality sign to make it true. All right, go ahead and pause. Copy this in your notebook. Highlight it, put some big stars around it, whatever. This is the only thing that you really have to remember to be successful at inequalities. The only way that they're different from equations. All right, class, I feel like that's good enough for today. So go ahead and get a good night's sleep. Make sure you got all that stuff copied down. And make sure you just like burn into your brain that when we multiply or divide by a negative, you got to reverse that inequality sign. And we'll do some examples with that tomorrow. All right, see you in class. Bye.